stoichiometry. Stoichiometry means calculations based on chemical equations. Stoichiometry is strictly based on the law of conservation of mass, the law of definite proportions, and the law of conservation of energy. We need a balanced equation for every chemical calculations. And this balanced chemical equation carry some qualitative and quantitative meanings. Let us see some of the quantitative meanings of a chemical equation, a balanced chemical equation which is needed for stoichiometry. See, I'm going to give you an example. Hydrogen plus chlorine gives hydrogen chloride. See, check whether the equation is balanced, because a balanced equation is only a balanced equation is valid for stoichiometry. So we have to balance this equation 2. Putting 2 here. There are 2 hydrogen atoms on left hand side and 2 on right hand side. There are 2 chlorine atoms and 2 chlorine atoms. Now, the qualitative meaning is hydrogen plus chlorine gives hydrogen chloride. Hydrogen plus chlorine gives hydrogen chloride. It is a qualitative meaning. Now, let us check some important quantitative meanings. See, the coefficient of H2 is 1. So, 1 mole of hydrogen plus coefficient of Cl2 is 1. So, 1 mole of chlorine gives the coefficient of HCl is 2. Therefore, 2 moles of hydrogen chloride. This is another meaning. This is a quantitative meaning. This is first meaning. This is the second meaning. This is the third meaning. See, the third meaning is this. 1 mole of hydrogen means gram molecular mass of hydrogen. That is 2 gram of hydrogen plus, see, there are 2 hydrogen atoms, so 2 grams of hydrogen plus chlorine. The atomic mass of chlorine is 35.5. So 35.5 into 2 is equal to, see, 71. So 71 grams of chlorine gives, see, there are 2 moles of HCl. 2 moles of HCl means, see, chlorine 35.5, hydrogen 1. So 36.5 into 2 is equal to 73 grams. So 73 grams of hydrogen chloride. 73 grams of hydrogen chloride. Now, let us check the fourth quantitative meaning, fourth meaning. See, the fourth meaning is this. See, 1 mole of hydrogen contain 6.022 into 10 raised to 23 molecules. 23 molecules of hydrogen plus there is 1 molecule of 1 mole of chlorine. So 6.022 into 10 raised to 23 molecules of chlorine gives, there are 2 moles of hydrogen chloride, that is 2 into 6.022 into 10 raised to 23 molecules of HCl. This is the next quantitative meaning. Now, dividing throughout by 6.022 into 10 raised to 23, we get fifth meaning. See, 1 molecule of hydrogen plus 1 molecule of chlorine gives 2 molecules of hydrogen chloride. Now, the molar volume value, the molar volume value means the volume occupied by 1 mole of a gas. It is 22.7 liter. 1 mole of hydrogen can occupy 22.7 liter of hydrogen at STP plus 22.7 liter of chlorine at STP, See, there is 1 mole and there are 2 moles of hydrogen chloride. So 2 into 22.7 liter of HCl at STP. See, this is the quantitative meaning in terms of molar volume. Now, let us divide throughout by 22.7. See, 7th meaning. 1 liter of hydrogen plus 1 liter of chlorine gives 2 liters of hydrogen chloride. Now, generally we can say that 1 volume of hydrogen plus 1 volume of chlorine gives 2 volumes of hydrogen chloride. Let us see some examples for this question. Calculate the mass of carbon dioxide produced by burning, B-U-R-N-I-G, burning 10 gram of methane, 10 gram of methane. See, you are asked to calculate the mass of carbon dioxide produced by burning 10 gram of methane. For finding the mass of carbon dioxide produced, we have to represent the complete balanced equation for the reaction. It is according to stoichiometry. See, methane is CH4. It reacts with oxygen forming carbon dioxide and water. See, it's a hydrocarbon. When a hydrocarbon burns in oxygen forms carbon dioxide and water. See, this is the equation. Check whether the equation is balanced. See, carbon 1, hydrogen 4 here, hydrogen only 2 here. In order to make it 4, put 2 here. Then oxygen 2 here, 2 into 2 plus 2 is equal to 4. So, in order to make it 4, put 2 here, coefficient 2 here. See, CH4 plus 2O2 gives CO2 plus 2H2O. Here, carbon, both sides are the same. Hydrogen, both sides contain 4. And oxygen, there are 4 oxygen in the left hand side and 4 oxygen atoms in the right hand side. Equation is balanced. Now, what we are asked to find is calculate the mass of carbon dioxide. See, put a question mark here. Mass of carbon dioxide. What we are supplied? 10 gram of methane. That is, we are supplied with or given 10 gram of methane. Okay. Now, according to the balanced equation, what is the weight of methane? Carbon 12, hydrogen 4. That is 16 gram. And according to the balanced equation, what is the mass of carbon dioxide? 12 plus 16 into 2, that is 32, that is 44 grams. Okay. Now, we can give the steps for doing this problem. See, mass of carbon dioxide produced by 16 gram of methane, 16 gram methane in the given equation, according to the equation, is equal to 44 grams. That is according to the stoichiometry of the equation. The mass of carbon dioxide produced by 16 gram of methane is 44 grams. Therefore, mass of carbon dioxide produced by what? 10 mass of methane is equal to, see, 16 can produce 44, am I right? So, what much is produced for 10 gram? That is, we are asked to find. Okay, that is 440. 440 divided by 16. 440 divided by 16. It is 27.5. 27.5. So the answer is 27.5 grams. We got the answer. It is the stoichiometric way of finding the mass of carbon dioxide produced out of 10 gram methane. Now, let us see another problem. See, question. Calculate the mass of oxygen required. Calculate the mass of oxygen required to burn 10 gram methane. That's the question. Calculate the mass of oxygen required to burn 10 gram methane. Okay. See, in order to find the oxygen required, represent the balanced equation at first. See, the balanced equation is the same as before. That is CH4 plus 2O2 gives CO2 plus 2H2O. That is the balanced equation. Now, what we are asked to find, calculate the mass of oxygen. So put a question mark over oxygen. And you are supplied with 10 gram of methane. See, 10 gram methane. Now, according to the equation, the mass of methane is 16 gram. According to the stoichiometry of the equation, the mass of methane is 16 gram. And mass of oxygen is, see, there are 4 oxygen atoms. 2 into 2, 4. 16 into 4 is equal to 64 grams. So we can write the steps as follows. First step is mass of oxygen required to burn 64 gram, required to burn 16 gram methane is equal to 64 grams. Therefore, mass of oxygen required to burn 10 gram methane is equal to 10 gram methane is equal to, see, 16 gram methane requires 64 grams. Therefore, for 10 gram. So, 640. See, this is 640 divided by 16. 640 divided by 16. That is equal to 40. So, it can be done as follows. In stoichiometry, there are 3 relationships. 1, mass-mass. Second, mass-volume and volume-volume. See, mass relationship. Here, mass of one substance may be given and asked to find the mass of the other. This type of problem was previously done. Now, the other is mass may be given and asked to find the volume of the other, or vice versa. That we are going to do. Third one, volume of one may be given and asked to find the volume of the other. See, now we are going to learn mass-volume relationship. Another problem. Question. Calculate volume of carbon dioxide produced at STP by burning 20 gram of ethane. In this problem, we have to represent the complete balanced equation for the process. See, ethane, that is C2H6. Ethane burns in oxygen forming carbon dioxide and water. Carbon dioxide and water. Balancing the equation, there are 2 carbon atoms, so 2 here. There are 6 hydrogen atoms, so 3 here. Now, oxygen, 2 into 2, 4 plus 3 is equal to 7. Here, it is only 2. In order to make it 7, 3.5. See, this is a fractional value. So, multiply throughout by 2 to get a whole number value. Multiplying by 3.5, it becomes 7. Multiplying 3.5 by 2, it becomes 7. Multiplying this by 2, it becomes 2. Multiplying this by 2, it becomes 4. Multiplying this coefficient by 2, we get 6. Now check whether the equation is balanced. See, there are 4 carbon atoms, 4 here. There are 2 into 6, 12 hydrogen atoms. Here also there are 12 hydrogen atoms, 6 into 2. There are 7 into 2, 14 oxygen atoms here in the left hand side, and 4 into 2, 8 plus 6 is equal to 14 on the right hand side. Okay. Now the equation is balanced. See, we are asked to find the volume of carbon dioxide. Volume of carbon dioxide. And we are supplied with the mass of ethane taken, that is 20 grams. Now, according to the equation, there are 2 molecules of ethane. You know, ethane, carbon 2 into 12 is equal to 24. Hydrogen 6 is equal to 30. That is the molecular mass of ethane. Now, 30 into 2. Why? There are 2 ethane molecules. So, 30 into 2 is equal to 60 grams. So, for 2 ethane molecules, the total mass is 60 grams. See, this 60 gram of ethane can give, see, 4 into 22.7 liter of carbon dioxide at STP. See, the molar volume at STP is 22.7. Now, we can give the steps. Volume of carbon dioxide produced at STP by burning 60 gram ethane, according to the equation, is equal to 4 into 22.7 liter. Therefore, volume of carbon dioxide produced at STP by burning 20 gram ethane, that is, we are asked to find 20 gram ethane is equal to, say, for 60 grams, the volume required is 4 into 22.7 liters. Then for 20 grams, it is this. That is 4 into 22.7 into 20 divided by 60. That is equal to 30.3 liters. See, therefore, 20 gram ethane can produce 30.3 liters of carbon dioxide at STP. This is mass-volume relationship. Calculation based on volume-volume relationship. Question: calculate the volume of ammonia produced by 1.2 liter of dinitrogen or nitrogen at STP. See, this is Haber process of manufacture of ammonia. See, in Haber process, nitrogen combines with the hydrogen forming ammonia. There are 2 nitrogen atoms, so 2 here. There are 6 hydrogen atoms, so 3 here. So equation is balanced. There are 2 nitrogen atoms, 2 nitrogen atoms, 6 hydrogen atoms. 2 into 3 is equal to 6 hydrogen atoms. Now, we are asked to find the volume of ammonia, and we are supplied with 1.2 liter of nitrogen. According to the equation, 22.7 liter, that is 1 mole of nitrogen, 22.7 liter of nitrogen at STP can produce 2 into 22.7 liter of ammonia at STP. See, there are 2 moles, so 2 into 22.7 liter. Step 4, calculating volume of ammonia produced by 22.7 liter nitrogen is equal to 2 into 22.7 liter. Therefore, volume of ammonia produced by 1.2 liter nitrogen is equal to, see, for 22.7 liter, the volume produced is 2 into 22.7. Therefore, for 1.2 liter, the value is 2 into 22.7 into 1.2 the whole divided by 22.7. The value of this is 2.4 liter. See, this is the volume of ammonia produced by 1.2 liter of nitrogen at STP. Here, one volume is given and asked to find the volume of the other. That is why we say volume relationship in stoichiometry. Let us learn limiting reagent or limiting reactant. It's a very important term in stoichiometry. Limiting reagent or limiting reactant is the reactant that limits the reaction to a particular extent due to its deficiency. Limiting reagent. Or limiting reactant. We can learn this term using a problem. Say, question. 6 gram carbon was burnt in 8 gram oxygen, which is the limiting reagent. Or reactant. Calculate mass of the reagent that remain unreacted. See, I'm going to repeat the question. 6 gram carbon was burnt in 8 gram oxygen, which is the limiting reagent. Calculate the mass of reagent that remain unreacted. First of all, we have to represent a balanced equation for the process. Carbon burns in oxygen forming carbon dioxide. See, this equation is balanced. 1 carbon here, 1 carbon, 2 oxygen atoms and 2 oxygen atoms. See, we are supplied with a 6 gram carbon. So, 6 gram carbon and 8 gram oxygen. 8 gram oxygen. According to the stoichiometry of the equation, 12 gram carbon reacts with a 32 gram, that is 16 into 2, 32 gram oxygen. Okay, according to the stoichiometry of the equation, 12 gram carbon burns completely in 32 gram oxygen. That is 12 gram need 32 grams. Okay. Now, first of all, we have to find the mass of oxygen required to burn 6 gram. Okay. Mass of oxygen required to burn 6 gram carbon. See, according to the equation, 12 gram carbon needs 32 gram oxygen. Therefore, what is the mass of oxygen for 6 gram? So, for 6 gram carbon, 12 gram need 32. So, what for 6 gram? Okay, therefore 32 into 6 by 12. See, that is 16 grams. Therefore, 6 gram carbon need 16 gram oxygen. But here there is only 8 grams. Therefore, oxygen is the limiting reagent. It is deficient. So, it is the limiting reagent. Due to its deficiency, 6 gram carbon will not burn completely. So, oxygen is the limiting reagent. Why? Because its quantity is or its mass is deficient. We need 16, but there is only 8 grams. Okay. Now, therefore, oxygen is the limiting reagent. Now, we can calculate the mass of carbon that burn completely in 8 gram oxygen. So, mass of carbon that burns in 8 gram oxygen, that is, according to this stoichiometry or according to the balanced equation, 32 gram oxygen need 12 gram carbon. That is, 32 gram oxygen burns 12 gram carbon completely. Therefore, the carbon required to burn 8 gram oxygen. See, so the carbon required to react with the 8 gram oxygen is 3 grams. So, out of 6 grams, only 3 gram is needed to react with the 8 gram oxygen. Therefore, carbon remain unreacted. So, how much carbon remain unreacted? See, carbon remain unreacted is equal to six minus 3, that is 3 grams. Yes. This concept is very important because when we use LPG gas and stove, if the stoves are not properly serviced, air supply may be deficient. So, oxygen become deficient due to blocking of holes in the burner. This causes incomplete combustion of LPG. This may lead to fuel loss and environmental pollution. See, that is very important application of limiting reagent, the concept of limiting reagent. Okay.